Hi friends, welcome to our channel Jayaditya Math Tutorial. So in our previous classes we have discussed a complete series of 10th class and now we are entering into the 11th class of NCERT here. So here mainly we are focusing on NCERT 11th class mathematics. So the very first chapter in your NCERT 11th class is the sets. Okay, so it is very important chapter. This is the very first class of your class 11th. So this class will be very important for you. So watch the video till the end. Then even if you have any doubts, you can do comment in the comment section. So without wasting any time, let us enter into our class. So what is our chapter, Nana? That is nothing but sets here, right? Actually the sets is the very fundamental concept. So we will be using this concept in our present day mathematics, and sets is a very basic concept which we use to define the relations and functions. So functions and relations will be very important. So to understand relations and functions very well, so you should have the basic concept of sets here. And also sets are also used to define some sequences like trigonometric sequences or any other things. So that's the reason sets has very important role in your mathematics. You should have complete concept of sets here. And the theory of sets, so who developed this theory is, that is nothing but he is the German mathematician. His name is Georg Cantor. When he has developed this theory means when he is working on the sequences of trigonometric functions, there he has discovered the theory of sets. So this chapter, in this chapter we will be mostly focusing on the operations on sets, and first of all we will be discussing the definition of set and what are the operations on sets, how to represent a set, so what are the types of representations, so what are intervals. So we have many concepts here. So we will be discussing each and every one by taking the examples and also by solving the exercise problems also. In our daily life, we will be talking about many collections. For examples, collection of some objects we will be talking about, right? Some collection of 3D objects or collection of 2D figures or collection of pack of cards, okay? And we will be talking about some collection of students of some particular class or collection of students of some particular school. So these are all nothing but these are some collection of some objects. So here each and everything will be treating it as an object here. So here we will be mainly discussing about these collections. So let us take some examples like collection of vowels. Collection of vowels. So what are vowels in an English alphabet? So here you can easily say that A, E, I, O, U, right? A, E, I, O, U are nothing but vowels of an English alphabet. That means, so whenever you are talking about vowels means you should have an idea about A, E, I, O, U. So you should have an idea that A, E, I, O, U are the vowels of English alphabet, right? So you can also take one more example like natural numbers less than 6. Natural numbers less than 6. So what are the numbers we will be getting here? So we can easily say that 1, 2, 3, 4, 5 like that, right? So what are the prime numbers less than 10? What are the prime numbers less than 10? So I am writing like this. So what are the prime numbers less than 10 means you can simply say that 2, 3, 5, 7. So these are the prime numbers less than 10. So see here, if you observe these collections, so you can easily find out a common property is involved in this everything. So whenever you are talking about vowels means you are talking about A, E, I, O, U. Natural numbers less than 6 means 1, 2, 3, 4, 5. Prime numbers less than 10 means you'll be talking about 2, 3, 5, 7, right now. So whenever you are giving a condition here, you have a specific values for that, right? Vowels means A, E, I, O, U. Prime numbers less than 10 in the sense that is nothing but 2, 3, 5, 7, right now. So you'll be having a particular answer for that one. No one says that is false here, right? So such kind of collections, these are the collections, right? So these are the collections known as well defined collections. So you can say these collections are like well defined collections. So this word is very, very important. What do you mean by well defined? So prime numbers less than 10, prime numbers less than 10, so that is well defined here. So everyone, if you ask anyone, so they should say the answer as 2 3 5 7 only, right? Natural numbers less than 6, natural number less than 6 means 1 2 3 4 5. If you ask anyone, they will be telling the same thing. Okay, and for example, if you ask like that, if you ask like who is the best batsman, best 5 batsmen in cricket team, means, so some may tell that Sunil Gavaskar is the best batsman, and some may tell that Sachin Tendulkar is the best batsman, and the viewers of cricket in this generation, so in this generation they may say that the best batsman is Virat Kohli, like that. So there is a difference in the values what we get here. So there the best 5 batsmen is not the well defined collection. Why? Because you cannot define that who is best batsman here. Is there any criteria to decide that he is best here? So we are not giving any criteria there. So we call that kind of collections as not well defined. Those are not well defined collections. So when we talk about these things, these are well defined collections. In our mathematics, we have many collections here. Without knowing the concepts of sets only, you have already learned that. So let us see what are those things here. Okay, right, Nana? Look here. Here we have some collection of some numbers here, which we have already learned without knowing the concept of sets here. But these are all nothing but we can say that these are sets here. Why? Because see here, the set of all natural numbers. You know what are natural numbers? What are the natural numbers here? 1, 2, 3, 4 and so on. So those are all the natural numbers. So all those numbers are like a collection. So we call that collection as a set here, and it is defined, it is denoted by letter N. And set of all whole numbers. So if you add 0 to the natural numbers, you can say that complete collection is nothing but whole numbers. So this is denoted by W. And set of all integers. So in the integers you will be having the whole numbers and also the negative numbers, and this is represented or denoted by the letter Z. Set of all rational numbers. Rational numbers means apart from integers, and if you also include some decimal numbers or fractions, then those all comes under rational numbers, and this set is denoted by the letter Q. Why it is denoted by Q? In the sense, rational numbers are also known as quotient numbers, so it is denoted by the letter Q. The set of all real numbers. In the real numbers, you will be having the rational numbers and also irrational numbers, which you have already know that one in your 10th class only, and even in your 9th standard you have learnt about rational and irrational. And though if you combine those two collections, then it becomes the real numbers, and it is denoted by the letter R. And these are some special cases here. So see here, the set of all positive integers. So we are talking about integers, but what is the special case here? That is positive. So how to represent this one? So integers are represented by the letter Z. So you can write here Z, and you want only positive, so it is denoted by Z plus. Okay, and positive rational numbers. Rational numbers is denoted by the letter Q, and we want positive, so you add there plus. And positive real numbers. The real numbers are denoted by R, and we want only positive, so positive real numbers is represented by R plus. So you should definitely know these denotations now, or these notations. Why? Because when you are learning the concepts of relations and functions, there you will be mostly talking about the concepts by using these symbols only. So sometimes they will be giving that Z plus. So what you need to understand there, if you see any Z plus there, you should understand that these are the nothing but it is the set of positive integers. If you find Q plus, like that, so you should understand that it is positive rational numbers. If you find only just R, so you should consider that that is the set of all the real numbers. So for that reason, you should definitely know all these notations. Okay now. So next we'll be discussing about the representation of sets and what kind of sets we have here. Okay, let us see that. Just by looking at the previous notations, there we have discussed about some collections there, and we are calling them as the set of natural numbers, set of rational numbers, set of real numbers, like that. So what you have understood from that thing, so it is nothing but set means it is the collection of well defined objects. Okay, so what is the set, Nana? Set is nothing but it is a collection of well-defined objects. I already told you what do you mean by well-defined. So natural numbers less than 6 means you will be having only 1, 2, 3, 4, 5. So that is well-defined collection. If you say that who is the best mathematician, so there is no correct criterion to decide who is best mathematician there. So there the answers will be different. Why? Because it depends on the perception of the individuals, right, Nana? Right, so we can say that set is the collection of defined objects. So see here we need to understand one thing here. So what are those things? We are telling that set is the collection of well-defined objects. So see here, in a set we'll be having some objects. So by looking at that one, you can say that the set contains some objects. So these objects are also known as elements, or you can also say that these are things. But how all these objects must be? So these must be like synonymous terms. That means it should have same meaning. So whatever the elements might be. So I already told you, 1, it is the natural number less than 6. 2 is the natural number less than 6. 5 is the natural number less than 6. So each and everything has the same meaning there. That means it contains some common property there. And next, usually sets are represented by capital letters. Sets are represented by capital letters. Already we have seen. So the set of real numbers. Set of real numbers is represented by R. Set of integers is represented by Z. So like this. So sets will be represented by capital letters. And one more thing, and the elements or the objects will be represented by small letters here. Objects of a set are represented by small letters. For example, so elements are represented by with the small letters like X, Y, Z, or A, B, C, like that. So for example, set of vowels, if you have taken set of vowels, so how you will be writing this one? So A, E, I, O, you write it. Okay, so in this way you will be writing, Nana. So you should understand these 3 concepts related to sets here. Right, Nana? See here, for example, if you see that if A is an element of set A, so see here, if A is the element, so I am representing it with small letter. If A is an element of set A, that is, this is the set, it is denoted by the capital letter. A is the element and A is the set. Now small a is the element and capital A is the what? That is the set. So A is an element of set A in the sense A belongs to set A, right? For example, 1 belongs to natural numbers. 1 is the element of set of natural numbers. So 1 belongs to natural numbers. 0 is the element of set of whole numbers, but it is not the element of set of natural numbers. So you can easily understand. So 0 is the element of set of whole numbers and 0 is not the element of set of natural numbers, you can say, right, Anna? So how you will be telling about this one means here you will be using a symbol to denote that 0 is the element which belong to set whole numbers. What is that one? So that is nothing but it is the symbol will be like this. We call this symbol as epsilon. Okay, so epsilon means whenever if you see the symbol epsilon, it is nothing but belongs to. You should understand this one, belongs to. So if I write anything like this, A belongs to A, that means A is the element which is belonging to the set A. So I am telling that 0 is not the element of natural numbers. So I will be writing like this, 0 is not belongs to. Not belongs to means just you write the epsilon and you strike it off. So this is nothing but not belongs to. So 0 not belongs to natural numbers. 0 belongs to whole numbers. Right, Nana? So in this way you can use the symbol belongs to and not belongs to none. So this is belongs to and this is not belongs to symbol. These symbols are very, very important when you are doing exercises. Then you can understand about this very, very clearly. Okay, for example, I am taking a set V. Right now, I am taking a set V, and in this I am taking set V as set of vowels. Set of vowels. So what are the elements I can have there? So I can have the elements as A, E, I, O, U, right? V is the set of vowels means I should have the elements as A, E, I, O, U. Right now. So you can say that A belongs to set vowels. If you have B, B belongs to vowels here? No. Why? Because B is a consonant but not vowel. So you can simply write it as B is not a vowel. Clear now? C is not, doesn't belongs to set vowels. E belongs to set vowels here. So just by looking at the condition. So what is the condition here? V is the set of vowels I am taking here. So I can say that A belongs to set V, B doesn't belongs to set V, C doesn't belong to set V. E again it is belonging to set V nano. So you should understand that one. So whenever you have seen a condition, you should understand what are the elements comes into that condition and what are the elements which do not come into that condition. So sets is the basic chapter. Just you will be learning only these things here, and you will be applying this concept in your relations and functions. That's why this chapter is very, very important right now. So do watch it till the end. Okay, right. Now let us see how many types we can represent a set. Okay now let us discuss about the methods of representation of sets here. Okay now, so the very first one you will be having that is roster form. So roster form is one method of representation of set, and the other one you will be having the set builder form. Okay now, so these are the two methods in which we will be representing a set. So let us discuss about each one. So in roster form, what will be happening means, so in roster form we will be listing all the elements of the set. We will be listing all the elements. That means we will be writing all the elements which comes under that set. For example, just now I told you I am taking V. V is the set of vowels. I told you V is the set of vowels. So if I take V as the set of vowels, so what are the elements I should get here? So I should get A, E, I, O, U none. A, E, I, O, U, right? So you should know one thing here. So always whenever you are writing a set in roster form or set builder form, the elements or the conditions must be placed within the braces or curly brackets. And in roster form, whenever you are representing a set in roster form, all the elements of the set must be separated by commas. And here you should also know one more thing, that is, here the order is not much important. The order is not much important. You can write in this way also, I, O, U, A, E. So this is also the set same as V nano. Why? Because here the elements are same but the order is different. So here you need not consider any order here. Okay, so elements in the set can be arranged in any order. So we will be generally telling that order is immaterial. That means it can be neglected. Okay now, so this is in this way you will be writing a set in the roster form. So roster form means nothing but you will be listing all the elements here. And you should also have one more condition. You should also know one more condition here. What is that in the sense? So if you have written one element here, you should not write again. So that means you should avoid repetition. You should avoid repetition. So you will be understanding this one by taking some examples. Let us see some examples now. Let us take an example here. The set of letters forming a word school. Right now, so this is our set here. So let us take it as like a question. The set of letters forming a word school. That means what is the set here? In the set we will be having some letters. So with that letters you can form the word school here. So how to write the set? So let us take the set as A. Here he has not given any set denotation here. So notation. So you can take any capital alphabet here. So I am taking the set as A. I am writing it in the roster form. So in the set, so what are the letters I will get? So I have S, so I should have S here, and C I will be having, H I will be having, O I will be having, and in the word you have 2 times O none, but you should take here only once. You should not write one more O here. Okay, so repetition is not allowed here. Okay, and what is the other letter here? So that is nothing but L. So if you have the question like this, set of letters forming a word school, that means when you write this one in the roster form, so what are the elements here? Elements of the set is nothing but S, C, H, O, L. You can also write like this. So you can also write like this now, C, H, L, O, S also. So this also the same set, but what has changed here? The order of the elements is changed here. The order of the elements is changed here. So this condition is also very, very important. So whenever you are representing something, so you should understand like this. Okay, so let us take some more examples. So see here, Nana. So you should write the solution set of the equation x square plus x minus 2 equal to 0. So you should write the solution set of this quadratic equation. So you should know how to find the roots of the quadratic equation. You have learned in your 10th standard itself. So how to find this one? Just let us try to factorize this one. So how to factorize here? So I am writing it as x square plus 2x minus 2 is equals to 0. So you know the process of factorization, I think. So I am writing it as x square plus 2x minus. 2x minus x is nothing but x again. So you take x common from the two terms here, first two terms. So if I take x common, I will be remain with x plus 2, and here if I take minus 1 as common, I will be remain with again x plus 2, which is equals to 0. And here I have x plus 2, here also I have x plus 2. Take x plus 2 as common. If you take x plus 2 as common, you will be remained with x minus 1, which is equals to 0. From this, what are the values of x you can take here? X will be minus 2 and x is equals to 1. So these are the concepts which you have learnt already in your 10th standard. Just for your revision, I told you this one. So what are the x values we will be taking here? Minus 2 and 1. But you should represent the solution set in the roster form. So how to represent this as in roster form is, let us take the set as A, and you will be representing the values here like this. That's all. So this is nothing but the solution set of the given quadratic equation. Clear now? So the question will be in this manner. So you should understand what are the elements. You should find out the elements and you should represent them in the form of a roster form. When you are representing it in the roster form, you can take any notation of the set. Okay, let us go to the next method, that is set builder form. Right, Anna? See here, we already taken one set here like set of vowels. So see here now, A, E, I, O, U. This is nothing but it is a set of vowels. So this is written in which form? This is in the roster form now. But when you are writing a set in the set builder form, there you will be mainly focusing on the common property now. So what is the common property in A, E, I, O, U? That is nothing but set of all vowels, right? So how to represent this one in set builder form? You observe here the syntax is very, very important. So how you are writing is very, very important here. So see here. So if you want to represent the same set in the set builder form, how to write means, see here. So V is the set, okay? V is the set here. So how to represent this one means, first you observe what I am writing here, x colon, and again x is a vowel of English alphabet. English alphabet. Right, now you understand this one. So this is the syntax you should definitely use when you are writing a set in the set builder form. And what is each and everything describes here, let us understand. So this brackets, so these two curly brackets says that the set of all, okay, and this you have x here. So for an element you will be assigning a variable here. For an element of a set you will be assigning a variable here. So here I have taken x. You can also take small a, small b, you can take any variable here. So the set of all x, I am taking here x. So what is this colon represents is such that. So colon represents such that x is a vowel of English alphabet, that everything comes next. So how to read this one means the set of all x, such that x is a vowel of English alphabet. So here you will be writing the condition in the set builder form now, right? So this is very, very important, and here you should mainly focus on the syntax, right? Syntax in the sense order, how you are writing. So these braces or these curly brackets you should definitely mention, and this colon is also very, very important, and you should assign a variable for the element of a set here. So these two have the same meaning, right? So this is the set of vowels of English alphabet, this is also the set of vowels of English alphabet, but the way of writing is different. The first way here we have listed everything, but here we have written the common property involved. So this common property gives the meaning same as the elements in the roster form here. So you will not get any other answer other than the elements. So do you get S answer for this one? No. Why? Because S is not a vowel. T is also not a vowel. U, yes, U is a vowel like that. So this is the common property you will be mentioning in the set builder form. So you can also understand this by taking some examples. Let us take some examples here. Right now, look at this example. So here we have a set A. In this set, what are the elements we have here? 1, 4, 9, 16, 25. So on. So these dots represent so on. That means there are some more elements. So you should represent this set in the set builder form. That means this set is in which form here? The set is in the roster form. So how to represent this one in the set builder form means, so first of all you take the set A and keep the curly brackets. I already told you. So first of all you understand what is the common property involved here. So 1 is nothing but 1 square, 4 is nothing but 2 square, 9 is nothing but 3 square, 16 is nothing but 4 square, and 25 is nothing but 5 square. So you can understand that these are all square numbers, right? These are all square numbers or squares of the natural numbers. So by understanding the common property, you should write the set builder form. So how to write? Let us see now. Simply write it as x such that x is a square number, x such that x is a square number. Okay, this is one kind of writing in set builder form. You can also use your own creativity also. Why? Because I already told you 1 can be written as 1 square, 2 can be written as 2 square, 3 can be written as 4 can be written as 2 square, 9 can be written as 3 square, right? So by using that concept also you can write. So how to write this one, let us see. So A is the set of all x such that x is equals to n square. I'll take it as x is equals to n square. Why? Because every x is nothing but it is an element, right? So element I am taking it as n square. Now I will write the condition for n. Now I will be writing the condition for n. So what is n here? N belongs to natural numbers. N belongs to natural numbers. That's all. So x is the set of all x such that x is equals to n square and n belongs to natural numbers, set of natural numbers. That means if you take here 1, you will be having 1 square. 1 square is nothing but 1. If you take n value as 2, 2 square. 2 square is 4. If you take n value as 3, 3 square. 3 square is 9. If you take n value as 4, 4 square is 16. N value as 5, 5 square is 25. Right? And here the set has some more elements. That's why we have taken complete set of natural numbers here. So I hope you have understood the concept of writing an element in the set builder form. So let us take one more example, then you will be having some more clarity. Okay, let me take one more example here. Right. Let us see one more set here. So B is the set. This is in the roster form. Why? Because we have all the elements and these are all separated by commas here. So just by looking you can say that the set is in roster form. You should convert this one into set builder form. So first of all you should understand what here. So what is the common property? You should understand that one. If you understand the common property, then you can easily write the set builder form. So understand here 1 and 2. 1 is in the numerator, 2 is in the denominator. So can I write 1 by 2 as 1 by 1 plus 1? Can I write it or not? Yes, 1 plus 1 is nothing but 2. And 2 I have here. And can I write it like this? 2 plus 1. 2 plus 1 is nothing but 3. And 3 by 3 plus 1. 3 plus 1 is nothing but 4. So 4 by 4 plus 1. 5 by 5 plus 1. And 6 by 6 plus 1. So you should be in a position that you should, just by looking, you should understand what is the relation there. Okay, so if you observe these things, I have numbers starting from 1 and ending at 6 now. So I have only natural numbers from 1 to 6. And in the denominator, if you observe here, if I put any variable in the numerator, I have the same variable in the denominator, right? So these two terms are same here. So how to write the set builder form is, so observe here. So the set of all x such that x is equals to, I am giving a variable here that is n by n plus 1, n by n plus 1. So in the set I have x. How is that x? The x is in the form of n by n plus 1. So what is the condition you should give for n here? N is not an, you should not directly write that n belongs to natural numbers. If you write like this, if you write n belongs to natural numbers, so what is the other answers? Let us see here. If I take n value as 8, if I take n value as 8, so my element must be 8 by 9 also must be my element, right? 8 by 9 in the sense it should be 8 plus 1, so this is nothing but 8 by 9, but we don't have 8 by 9 in the set. So you should not directly write as n belongs to natural numbers n here, but you can write it as, see here, 1 less than or equals to n less than or equals to 6 nana. Okay, if you write like this, 1 less than or equal to n or less than or equals to 6, that means n can take the values of 1 to 6, n can take the values of 1 to 6 none. So if you put 1 here, 1 by 1 plus 1 is nothing but 1 by 2. If you take 2, 2 by 2 plus 1 is nothing but 3. If you take the value of n as 5, 5 by 5 plus 1 is nothing but 5 by 6. 6 by 6 plus 1 is nothing but 6 by 7. So you should not take n value as 7. Why? Because in the condition I have given that n can take the values of 1 to 6 only. So there is no possibility for us to take the n value as 7. If you take n value as 7, again 7 by 7 plus 1, that will be 7 by 8, and we don't have that element in the set. So how to write this one now? So x is such that x is equals to n by n plus 1, and what is the other condition here? 1 less than or equal to n less than or equal to 6, and close the bracket. That's all. So this is nothing but the set builder form of the given set. Clear now? So in this way you can convert a roster form into set builder form, and also you can convert a set into roster form from set builder form also. For example, if the question is like this, convert the given set into roster form. So already we have the values here, so substitute each and every value. If you substitute 1 in place of n, you'll be getting 1 by 2. If you substitute n is equals to 2, you'll get 2 by 3, and if you substitute n is equals to 3, you'll be getting 3 by 4. If you substitute n is equals to 4, you'll be getting 4 by 5, and if you substitute n is equals to 5, you'll be having 5 by 6, and if you substitute n is equals to 6, you will be having 6 by 7 right now. So the condition is satisfied here. So these are nothing but, these are all the elements of the given set B. This is nothing but again the roster form. So you can convert a set into roster form, from roster form into set builder form, and also from set builder form into roster form, which is very, very important. So we will be understanding the importance of this concept in our coming class. I hope you have understood this concept very well. So this is the very, very first class, so I have explained all this in detail. If you want, you can also see the same concept in my previous classes. There also, in when I am explaining the 10th standard, there also we have taken the concept of sets. So you can watch this concept from there also. If you go to the playlist, there you'll be having the sets concept class 10th. So there also you have the same concept here, but for 11th standard I have explained you in detail here. I hope you have understood this class very well. If you like my class, please do like it and share with your friends, and if you are new to my channel, please do subscribe, and if you have any doubts, you do comment in the comment section, and also your opinion is very, very important for our channel. So kindly give your opinion or your feedback in the comment section so that we can change accordingly. In our next coming classes, let us solve some exercise problems, then we'll be entering into some other concepts. There we'll be going in a good pace. Okay, so do watch our channel regularly, and whenever you're watching any class, do watch it till the end. So let us meet in our next class. Till then, bye.